everyone, welcome to this video where we are going to go through a series of questions in preparation for assessment. So for this particular question here, we are given a diagram with a pole of height 800 cm and there is a string of colored flags tied tightly from the top of the pole to a point on the ground that is 6.5 meter away from the pole as shown in the diagram. Find the length of the string, meaning that they are actually looking at finding this particular length here. And we can safely assume, or not safely assume, but the question actually indicated to us that this is actually a right angle triangle. So from here we can then tap on our knowledge of Pythagoras theorem. Yeah, where if I have this as C and this as my A and this as my B, by Pythagoras theorem, my C square is equals to the sum of the square of the A and the B, meaning C square is equals to A square plus B square. And so we could then find this length since the length is denoted by C. So I could let C be the length of the string of colored flags as shown. At this stage, do take note of one very important point. They are given in meters, so this is good. But this 800 cm is not in meter. So we should express this in terms of meter first before we apply the formula direct. 6.5 square plus 8 meter square. This will give me a value of 106.25. And so the final answer, my C is simply the square root of 106.25, which will be 10.3078 to 6 as 6 significant figures. Final answer, 3 significant figures. The next question that they will actually want us to find is that for each meter, it is $5.50. And so, what is the cost of buying this string of colored flags? So the cost is simply equals to 10.3. Notice what Mr. Tan did. Mr. Tan did not use the 3 significant figures value. Rather, I'm using the 6 significant figures value because that will ensure the accuracy. For each meter, it is $5.50. So this will actually allow us to find the final answer, $56.6929. And finally, the final answer to the nearest cent, which will be $56.69. And that will be the solution to this particular question. Let's move on to other questions in this mock assessment. Hello everyone, welcome to this question where we are given that Melody, this girl, claimed that a triangle of the following sides is a right angle triangle. Is her claim true? Do show your working clearly to support your answer. So I'm going to apply my Pythagoras theorem, which states that if it is a right angle triangle, then my c square is equal to a square plus b square. Right? So this is what we are going to find out. I'm going to first find what is my ab square, which is 27 square, and this one gives me a value of 729. Then I'm going to look at these two values, which is AC square and BC square. And what is the sum of this? Well, if they give me back 729, then this is indeed a right angle triangle. But it turns out they give me 765, which is not 729. And therefore, with this, I am then able to conclude that her claim is actually incorrect. She is wrong. So, since my AB square is not, this means not equal to AC square plus BC square by the converse of Pythagoras theorem, this triangle ABC is not a right angle triangle. So Melody is wrong. Alright, the key things to take note of is, notice how Mr. Tan here presents my answer. I do not straight away write AB square equals to AC square plus BC square. Rather, I find them separately. Before I compare the values. And if they are equal, yes, it is a right angle triangle. But if they are not, then they are not. They are not a right angle triangle. And this is also another keyword. You do need to let people know that we are actually applying the converse of the Pythagoras theorem. That will help us to support our answer. Alright, let's move on to the next question. Hello everyone, welcome to this part of the video where we are given that of the interior angles of an n-gun. So in this case here, right, n simply represents a polygon or a figure that has n number of sides. Find the number of sides. So n is the number of sides, right? And we are given the sum. So sum of interior angle also have a formula where n minus 2, if I multiply by 180 degrees, is the sum of the interior angles. So 180 multiplied by n minus 2 is 1620. I'm going to tap on my algebraic skills to help us solve for this, okay? So n minus 2 will be equals to, what do you think we should do to the 180? Yep, we are going to divide by 180 on both sides. So this is what you will see. And that will give me, this will give me 9. And so n will be equals to, what's the next step? Yes, I'm going to add 2 on both sides such that 9 plus 2. So n minus 2 plus 2 will be Zn. So this one will be equals to 11. And with that, I gotten the n number of sides. This is a 11 gone, 11 sides. Part B. Each exterior angle of a regular n-sided polygon is 30 degrees. This is a very important word because this means that all the exterior angles are equal. And each exterior angle is 30 degrees. We also know another important fact, okay, which is that the sum of exterior angles is 360 degrees. And if each exterior angle is 30 degrees, how many exterior angles are there? Which also could lead us to how many sides are there, because the number of exterior angles and the number of sides are the same. So actually n can be simply, we would just need to divide by 30 degrees, since each exterior angle is 30 degrees, means 30, 30, 30, 30, 30, 30. How many 30 degrees are there? Yep, we are dividing by 30. And that will give me 12. And therefore, from that, we would be able to get that this n-sided polygon has 12 sides. N is 12. Right, let's move on to the next question. Hello everyone. So for this part of the question of the paper, we have this figure ABCD, which is a trapezium. And X is on the point BC such that we have a 90 degree there as shown in the diagram. Find the length of AX. That's where I would zoom in to this right angle triangle here, because then I would be able to apply my Pythagoras theorem, which states that ax squared plus 7 squared will be equals to 25 squared. So from here, after I apply my Pythagoras theorem, I would be able to then solve for it. What do you think we need to do here? Yes, we will need to minus away this 7 squared. And therefore, I would get that ax squared is equals to 576. The last step will be to square root 576 to give me 24 cm. Hence, part B then require us to find the area of this trapezium. At this stage, do take note that I hope you all remember area of a trapezium is equals to half times the sum of the parallel sides times the height of the trapezium, which is the perpendicular length. And in this case, we've successfully gotten the height. This is 24. We also can get the sum of this parallel side easily. And therefore, from here, I would then be able to get the area 528 cm square. With that, we have come to the end of this part of the video. And let's continue to solve for other math problems. Hello everyone, welcome to this problem where we will need to construct a triangle ABC where the length of AB is 8 cm, the length of BC is 6 cm, and the length of AC is 10 cm for part A. Well, this is the answer, but I do want to draw your attention that it would be good after we gotten the length of AB 8 cm. This is what I would want to share with you, that for all the construction, these are what we call arcs. And where does the arcs come from? The arcs come from the compass that we used. Okay? And this is important because this serves as an essential working. So we do not erase these arcs. Okay? They are essential working. Okay? To illustrate that we are using a compass to draw the length. Okay? And for the next part of this question is simply to use a protractor to measure this angle. Okay, so in this case it's 90 degrees. All right. So this is for the construction question. And let's move on to the next question. Hello everyone, for this part of the question where we are given this diagram where triangle ADE is mapped onto triangle ABC by a enlargement. Okay, we do not know the scale factor, it is K. But for part A, we do need to find this scale factor. Okay, so for those who are not very good at seeing such overlapping triangles, my advice to you is to draw separately. I have the big triangle, and in this case here, AB is simply 20. I am also going to draw this small triangle out here. That will help me a lot. Here's it. Because then I can make use of these two corresponding sides to help us to find the value of k, which is the scale factor. Okay, so k is equals to, we always divide by original. So in this case here, 8 is the original, 20 is the enlarged image. So take note, we always divide by the original length. In this case, it will be equals to 5/2 or 2.5. Okay, we accept either of this answer. So the blue color triangle is 2.5 times larger than the red color triangle. Okay, now once I know that, I will be able then to find my DE, because then I know from 25 is the enlarged version. DE would then be simply 25 divided by 2.5. 10. Because 10 times 2.5 is 25. Yeah? And with that, we've come to the end of this part of the problem. And let's move on to the next question. Hello everyone, welcome to this part of the video where we are looking at map scale. 2 cm on this map A represents 3.4 kilometer. For the first part A, we will need to write the scale in this form. Very first thing is both must be in centimeter. Okay, so let's start. We will have 2 cm representing 3.4 kilometer. My very first step is, since we need to get it to 1, I'm going to divide by 2, divide by 2. And the last step is, of course, to convert this 1.7 kilometer into cm. And if you're not very good at converting straight to cm, then you can actually do like what Mr. Tan do. I will convert this to meter by multiplying by 1000. Then multiplying by 100 will give me in cm. So now I know this is 1 and this is this value, 170,000. That's for part A. Part B. The length of a road on the map is 7.2 cm. What is the actual length? In meters. Okay, so for this question, notice I will use this because first, I don't like to deal with very large numbers. So I start with 2 cm on the map. Represents 3.4 kilometer on the actual ground. This is on the map. And once I have this, I could then, since they are dealing with meters, right? But before that, I will find this 1 cm to 1.7 kilometer first. And then 7.2 cm. So I know times 7.2 times 7.2. So that 1.7 times 7.2 will give me 12.24 kilometer. But that's not what they want us to leave our answer in. So final answer, I still need to convert this to meter by multiplying by 1000. So what's the catch here? What's the key? Notice Mr. Tan used this scale because it is easier. Numbers are smaller. Okay? And with that, for part C, if we are dealing with area, then we will need the scale for area. How do we do that? We will start off with 1 cm on the map. Represents 1.7 kilometer again. And this is what we are going to do. I'm going to square the scale. So 1 times 1 will give me 1. So 1 cm times 1 cm is 1 cm square. 1.7 square, this will give me 2.89 kilometers square. And so I will be able to get, this is what my scale for the area is. I will then be able to get this easily. I just need to multiply by 52. 150.28 kilometers square, and that will be the answer for this question, exact value. Alright, with that we have come to the end of this particular problem on map scale, and let's move on to the next question. Hello everyone, welcome to this problem on pyramid, square pyramid, and the sides are given. So for part A, right, they want us to find this slant height using Pythagoras theorem. I hope you can see, if I zoom in, that there is a right angle triangle here. And so that's what we are going to draw here to help us to see. And if this is at the center, so what do you think this length is? Yes, it is 4 cm. The height is 11. And so we are going to let L be the slant height. So it will be good to let people know that we are letting L be the slant height. So that we can tap on our knowledge of Pythagoras theorem like this. And what is 11 square plus 4 square? 137. So my L is square root of 137. This will be equals to 11.7047 to 6 significant figure first. Final answer 11.7, which is to 3SF. Okay. Hence, find the total surface area of the pyramid. Now that we have the slant height, this is important for us to take note that there are 4 triangles. And these 4 triangles are the same. There is also a square base below. So if I were to draw this net out, right, it will look like this. This net will actually allow us to find the total surface area easily. With the 4 triangles, same. This is 8, this is 8, and the slant height is actually the height of the triangle. In this case, I'm going to use square root 137 because it is really the most accurate. And so you will see that the total surface area will be equals to half times base 8 cm times the height square root of 137. This is for one triangle. How many are there? 4 of them. Plus 8 times 8, because this is for my square base. And this will be equals to 251.275 to 6 significant figures, followed by 3 sig fig, 251 cm square. Well, for the volume of the pyramid, the formula goes by 1/3 times the base area times the height of the pyramid. And if I go back to the question, they do give me the height of the pyramid, 11. Base area is 8 times 8. I still have my 1/3. And this will give me a value of 234.667. 6 significant figures followed by 3 sig fig, 235. With that, we have come to the end of this problem. So let's move on to the next question. Hello everyone. For this problem, we are given a prototype of a chocolate in the shape of a cone as shown. Oh, the key question here is that we must leave everything in terms of pi. So when we calculate, we do not calculate or key in the pi in the calculator. All right. Volume. Let's look at the volume. Volume of a cone is 1/3 times the base area. In this case, is a circle. So a circle will be pi r square. And the height of this particular cone, height of the cone, is 4. So this gives me a value of, when I key in, do take note, I only key in to my calculator 1/3 times 3 square times 4. Okay. 12 pi. So the answer is 12 pi in terms of pi. Okay, that's what we meant by in terms of pi. The total surface area of this cone. Alright, so now that we have all the necessary dimensions, so the total surface area, of course, we need to include that circle, right? And that circle is pi r square. We also need to include the curved surface area, which is equals to pi times the radius 3 times my slant height here 5. Again, because we are going to live in terms of pi, so this particular question, I only need to find out what is 3 square plus 3 times 5. Okay, that will be 24, and this will be 24 pi. Okay, Next, we have this particular chocolate cone. That is going to be melted. And after they melt it, they're going to make it into a cylindrical prism. Very important. The volume, do you think it has changed? Yep. Volume does not change. And we can tap on that. And so, now that we have this cylindrical shape, where they give us the height is 3 cm, find the radius of the cylinder. Okay, since the volume does not change, I'm going to look back at the volume of the cone, 12 pi. So volume of this cylinder is base area times height. So base area is pi r square, this is the base area, times the height, 3. This is equals to 12 pi. The volume, because volume does not change, same volume, 12 pi. Okay, so I'm going to apply my algebraic skills. I will have 12 pi dividing by pi and dividing by my 3. This will give me 4. And therefore, my r is the square root of 4, 2. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up and subscribe to my channel. Thank you for watching and have a nice day.